Alright, I've been having issues with Loom, so we're going to do it this way. So a second time, I was partway through a video and it blacked out on me. So I'm not happy about that. So I'm going to go this way. You can't see my face. It's life, you know? It's all good. But you can hear me, right? So we're going to skip the first number 6, just so you know. And I think you're okay with that. The second number 6 is about a ship, and so I've started the work here. I actually already did on the other video, so I'm just, right here it is. You have your right triangle, you have 2 ships. This one's B, and this one is A. And we've labeled X and Y, and the first question is how far apart are the boats when we have X being 4 and Y equals 3, the Pythagorean theorem, and the answer is 5 kilometers. Then in the question it says the rate of this boat B is going 10 kilometers an hour, and then it's going away from the lighthouse. For dx by dt, this boat is going towards the lighthouse at a rate of 15. Now why is it negative? Because it's going towards the lighthouse. This side is getting shorter and this side is getting longer. Then which formula connects it all? X squared plus y squared equals c squared. Take the derivative, so x squared, it's 2x with the hook dx by dt. Y squared is 2y with the hook dy by dt. This is going to be 2c with the hook dc by dt. This is my goal, is to find the rate that the distance between the boats is changing. I plug in all of these numbers into here, all of them, for x, dx, and so on, all the way across. 2 times 5 is 10, so just divide by 10, and you don't even have to simplify it, and that gives you the rate. If you did simplify it, you'd see the answer is -6 kilometers per hour, which means the distance between the two boats is getting shorter over time. Okay. The next question, part C, has to do at what rate is the angle changing when these values are here. So I rewrote the triangle. This angle, don't think of the 5. If you look at here, opposite over adjacent, that's tangent. So when I have tangent from this angle, that's y over x. So that's where that comes from, this triangle. And then the derivative of tangent is secant squared with the hook. The derivative of this is the quotient rule, the bottom times the derivative of the top minus the top times the derivative of the bottom, and the bottom squared. And then you plug in values. So secant is the reciprocal of cosine. So it's hypotenuse over adjacent. So from this angle, it's hypotenuse over adjacent, 5 over 4. That's why I plug in. These other numbers are the same numbers I used before to plug in. So what x is, the rate for y, what y is, the rate for x. Plug them all in, including on the bottom 4 squared. And then I simplified it, and I got 85. I simplified 25 over 16, and then I multiplied times the reciprocal to both sides. The 16s cross out, and I get 85 over 25, and the unit is radians per hour. All right, on to the next question. I know that was quick, but I was frustrated that I did all that work, and then the video just blacked out on me for Loom. So I think I'm going to have to do this until Loom figures something out. So the volume V of a cone, they give you the formula 1/3 pi r q squared h, is increasing. So dV by dt is increasing at a rate of 28 pi cubic centimeters per second. At the instant the radius is equal to 3, the volume is 12 pi. And the radius is increasing at a rate of 1/2 centimeters per second. And this would be cubic per second. And then the question is, at the instance the radius of the cone is 3, what is the rate of change of the area of the base? Here's my cone. And so this base, the area formula would be just pi r squared. And so what at that instance, the radius of the cone, what is the rate of change? The derivative. So the derivative of A would be 1, but it needs the hook. The derivative would be 2 pi r, but it needs the hook. And then you plug in values that you have. And so we said the radius is 3, and the radius is changing at a rate of 1/2. And this answer would be centimeters squared per second because it's area. Next, part B. If you would simplify it down, 2 times 1/2 is 1. It would be 3 pi. But we don't need to do that. Part B. At the instant when the radius of the cone is 3 centimeters, what is the rate of change of the height? So we first have to change. So we have the formula for volume, 1/3 pi r squared h. We're asked to find at what rate is the height changing. We're told the height is 4. So we're going to take the derivative here. This is going to be the product rule. So the first times the derivative of the second plus the second times the derivative of the first. And this needs a hook. And then we plug in the values that we used up here, right? Down here. So the volume is changing. It said is at 28 pi. So dV by dt is 28 pi. The radius is 3. dH by dt is what I'm looking for. The height is 4. The radius again is 3. And dr by dt is 1/2. Alright, so I have all the numbers, I just need to get that. So I'm not worried about simplifying it, so I'm just going to subtract all of that without simplifying it. And then I'm going to divide by what's in front of dH by dt. That's 1/3 pi 3 squared. I'm not worried how it looks. And then what would the unit be? Would be in centimeters per second. Part C. In part C it asks, at the instant when the radius of the cone is 3, what is the instantaneous rate of change of the area of its base with respect to height? So we're looking for this, the area with respect to height. That's equal to the area with respect to time times the time with respect to that height. And then we plug in the numbers that we have. So dA by dt, we got that at the beginning right here. That's 3 pi. And then dt by dh, that's the reciprocal of the answer we just got. So if I simplified this, you would have gotten 8. So the reciprocal of that would be 1/8. And that would be centimeters squared per second. I know, part C was confusing. But part A and B are very much where we need to be at. All right, next question. 2 more left. In number 5, you are given a picture of a cone that's dripping water into a big cylinder tank, and it gives you information that the height is 12, it's labeled, the diameter is 8, but we really need the radius, we'll do that in a second, and that the conical tank has a base with an area of 400 pi. The depth of h in feet of the water in the tank is changing at this rate, feet per minute. And then again, it gives you the formula for the volume of a cone. So part A, it says write an expression for the volume of water in the tank as a function of h. So the conical tank, the cone, the volume is 1/3 pi r squared h. If I want it in terms of h, I have this cone. I know the radius is actually 4 because it's half of 8, and the height is 12. And as water goes down, this becomes similar triangles. So if this is the radius and this is the height, you can see that the radius is always 1/3 the height. In other words, you divide by 3 to find the radius. So then we have too many variables here. So we're going to plug in 1/3. We want to keep h. So plug in 1/3 h for the radius. We're going to simplify this. That's 1/9 pi h cubed. And then we're going to take the derivative. So that's 3 times 1/9. Oh, wait a second, I did that wrong. You know what I did wrong? 3 squared is 9, and 9 times 3 is 27. That should be 27. Now when I go 3 times 1/27, it becomes 1/9. And then make sure you remember the hook. And then we have numbers to plug in. So for the height, it says the height is well, that's it. Oh, they even say to take the derivative. Just write an expression for the volume. So actually, it ended right here. There's no rate or anything else. So it said find an expression for the volume that only involves height, and we did that. Now part B says, at what rate is the volume of water in the tank changing when h is 3? So yes, now we take the derivative. Wow, I already scratched it out. That was silly. So when I take the derivative now, I get 1/9 pi h squared, and then the hook dh by dt. And now I plug in the values that I have. So the height is 3, and the height is changing at a rate of h minus 12. And if the height is 3, then 3 take away 12, that number would be -9. So again, we plug in 3 for h, and 3 take away 12 is -9. And that's it. I don't need to simplify it, even though I could. And that would be in the unit feet cubed per minute. Part C. It says, let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing with respect when h is equal to 3? So I'm given that the volume from the beginning this is complicated. I'm not going to do it. So in part C, or maybe I'm looking at the wrong, I'm looking at the wrong one. I was looking at the next one. Maybe the next one's going to be complicated. So the volume in this tank, the base is 400 pi times the depth, which is y. That's the volume. The rate of change for this is, anyways, we're going to take the derivative of this. So dv by dt, and then this is going to be 400 pi. Y is 1, but we need the hook dy by dt. Now the volume for this is going to come from this. So this is emptying, right? The cone is emptying into the cylinder. So the volume is changing based on this being dropped into here. For this it's negative because it's getting less, but the other tank's getting bigger, so it's positive. So this actually, the 9's cross out, it's negative 9 pi. But here it's going to be positive 9 pi. So the volume is increasing by it instead of decreasing because it's getting bigger down below. Okay. And then divide and you have your answer. So it's 9 over 400 and it's, again, feet cubed per minute. Oh, it's just the y, right? So it's just feet per minute. And that's how the depth is changing. Tough, right? All right, one more. I'm glad you're sticking with it. Last one. These are some of the tougher questions to do with related rates. All right. This one actually is not a related rate question. So, here it says you have an oil tank shaped above, and you found that shape by taking this equation and revolving it around the x-axis. Oh, the y, about the y-axis, so it's actually sideways going this way. Where x and y are measured in feet, oil flows into the tank at a constant rate of 8 cubic feet per minute. Find the volume of this tank. So volume is an integration question. So we're going to integrate, and it's the y. So we're going to integrate from 0 to 9. Now, because it goes around the y-axis, I have to take this equation and solve for x. So I need to get x by itself. So I'm going to do the reciprocal and then the fourth root of that. And that's what x equals. That's what I need. And then when I go right, subtract left, we're going to go pi r squared, there's only one circle, dy, and then you'd use your calculator, and you get 471.239 feet cubed. See if I'm right. For the next one, part B, to the nearest minute, how long would it take to fill the tank if the tank was empty? So the rate is 8 cubic feet. So you would just take this answer and divide it by 8 cubic feet to know how much time that would be. And again, if you use a calculator, it's about 59 minutes to a whole number. It says to the nearest minute, and it would take 59 minutes. So in the question it says the rate is 8 cubic feet per minute. You divide, and that's how many minutes it would take to fill up the tank. Part C, let H be the depth in feet of it. How fast is the depth of the oil in the tank increasing when H is equal to 4? So we know the rate it's filling up is 8. I want to find dH by dt. The volume, we said, was this. But now I actually don't know the height of it, 9. We're trying to figure out in terms of H. And again, it's the fourth root of 625 over 9y. Then when you take the derivative of this, the derivative and the integration cross out, and you're just left with pi and the fourth root of 625/9. But now this becomes h instead of y. When you do that, you just plug it in. But we need the hook dh by dt. And then we said the volume is changing at a rate of 8 cubic feet. That's what that's equal to. And then I just need to, the height. And they said when the height is 4. So plug in 4. And I'm looking for dH by dt. So the last step is to divide and use your calculator. So divide. And use your calculator. This is going to be dH by dt. And if you did it right, you get 0.153 feet per minute. All right. Those are like tough questions, right? So that's level tier 1. You do those at the end, right? And do the best you can. I am so proud of you. You didn't give up. You're doing your best. Thank you. Mr. GMath. Over and out.